Hello, this is David Birch at Star Path School of Navigation with a follow-up to a video that just got posted a little while ago about loading weather map images into Expedition for the purpose of comparing the raw GFS grid file model data to the actual forecast, graphic forecast made by the National Weather Service. And in doing that, though they loaded and it was so on, they loaded just fine. Well, not just fine, but they loaded. And then in the process of discussing it, we saw that the particular example chosen at random actually was an interesting one in that the two models were rather different. I mean, one is a model and one is a sort of a compilation of many models. But they were notably different. But the problem in doing too much study of it, or an in-depth study, was that I could not zoom in very well to get a nice scale in the Expedition presentation I was using. And the simple problem there is the image file was simply too big. It was just way too big. And the way around that is simply to trim down before you put the files in. Go in there and let's just find this one I just did, or like this one here. See, here's the one we were looking at. Where was it? Here, this one. We're looking at this great, oh darn, I gotta fix that. We were looking at this big map of the whole ocean, the 48-hour forecast. But all we're really caring about, say for a Transpac type race, you're only looking at this part of the world here. So I'm sticking this whole thing in there, and that's how it makes it hard for the Expedition to compare, to zoom in on that and at the same time show a base map, show the grid files and everything else. So the simple trick is to go in and oh, what is wrong with that? I'm going to change that default. This is then just trimmed down. You can cut it down that much. That one's just cut in half. Or the one I'm going to actually do is cut even more, which is down like this. This one here. You see, so it's just cut down right to the part we care about, this part of the ocean here. So this is a valid 48-hour forecast, but just that corner of it. Then if you input just that corner, or even just half, but the main thing is just not that whole map, you get a much better presentation. See, before I could only zoom like this, and now we can go in here. Let's see, this is that map loaded in here. And we get a nicer picture of the whole ocean with these with the overlay. Now, in the process of doing that, I noticed that these were quite a bit different. Here's the isobar. This is the 1016, and down here, what's this tooltip? You see here you have 1016 down here. They have 1016 clear up here. Plus there's this front. And that's always an issue when you're looking at just a pure GFS model. The fronts, the winds around the fronts are not going to be predicted as well as they could be. So we anticipate differences in the area around the front, and especially over here where these isobars are so far off. In other words, if this is really the isobar, GFS thinks the isobar is like this, they think the isobar is like this, and the wind's going to cross the isobar like at an angle like that. So these wind angles are going to be a little bit off. Now, here's then the next point. This graphic model of the National Weather Service forecast, this graphic picture, is also actually in digital format, in a digital grid format that we can load into Expedition. Now, it doesn't cover the whole ocean, but it's there. And so what I did just now is I used what is also not such a well-known opportunity, but you can actually go into SailDocs and ask for an old map Old meaning within 30 days. So any map within 30 days, you have to know exactly how to ask for it, but you can actually go to SailDocs and download an old map, so old data. So I went to SailDocs and asked them with an email request to give us the NDFD data for this same time. Oh, that's not the right time. Oh, yeah, it is. 12 Zulu. 12. It has a 44-hour forecast. We're dealing with roughly 48-hour, 44-hour forecast, but we're looking at the time. These models were all run at, like 44 hours ago, 48 hours ago. And this is 12Z on February 19th. But this NDFD data does not have isobars, by the way, but it doesn't cover the whole ocean. This is where this is all it covers. It covers out that far up to here and out to here, down here. And why that's true and why it doesn't go clear to Hawaii, I don't know. And why not? Actually, it does go over here. It does go here. I just didn't ask for that. So, but now, so again, I want to stress what this NDFD is. It is the digital presentation of these winds right here. So these winds here are actually reflecting what they believe is taking place even in presence of this front. So now we can look at rather dramatic differences. First, there's subtle differences down in here, and I've got them both loaded. So here's a GFS. And I got the isobars already in there, but so here we look at the GFS winds. That's these here for the same time, 12Z on that, and then you switch to the and that's what it's called. That's what the NDFD is called when presented inside of Expedition. And these are those winds. So if you look through here, you see a notable difference here between these two forecasts. So this is exactly the point I've been trying to make, namely why it is important to compare the actual forecast from the National Weather Service with the raw GFS data, which is often going to be different in ways that are very important, but also, more to the point, there are ways that you can figure that out and tell what is right. Because let's say you happen to be sailing through this area here, and let's see, 31, 30. You could well be here in a Transpac or something like that. But you see, here's a GFS. Now just watch the winds in this area here. That if all you had to plug into your program with GFS, you'd be looking at these winds right here. But this is now this is the best forecast that the National Weather Service has to offer. It's this kind of winds. Same time, 12Z, 1900, 19 Zulu, 12, 22, compared to this. Okay? So that's the exercise that I'm proposing would be very valuable if you want to really select the optimum winds that you're running your routing programs on. And just accidentally, the example I was working up to just fell in place during the demonstration of loading the maps. So this will be then a follow-up to the first video on loading the images.